Thanks. Hey, everyone. I'm very happy to be here tonight. So I'm Raphael. I'm a solution engineer at Algolia. I've been there for about a year. And so I'm going to talk about hosted search API and the challenges we had into packaging for enabling offline search. So today's meetup is all about APIs. And as a developer, when I think about APIs today, I automatically picture a set of methods to enable me to communicate from a client side to the server through the internet. But can it be more than that? At Algolia, we really strive to provide the best search experience possible to all users in all conditions, meaning desktop, mobile, and why not even on the airplane, so without connection. So a few steps of the presentation. First, I'm going to detail a bit what is Algolia, what we do, the feature and our core focuses. And then I'm going to deep dive into the why and how did we decided to go and provide this and release this feature of offline search, which is pretty new. And the last part will be a few snippets of code around how to implement it in a Swift client for iOS mobile. So our core focus is an API. So that's the product we have. As I said earlier, our main goal is to provide the best search experience to the end users. The way we do that is focusing on three main points. The first one is relevance, because providing a good search experience starts with good content. The second point is you want to provide that in a really fast way. So we strive to go below the 50 millisecond bar so that we can provide a good search experience, what we call search as you type. The second point is that we want to build those kind of cool search experience. We want to enable developers to quickly implement it and provide them with all the tools necessary. So API clients, UI libraries, to make their work really easier. And to also be able to build those cool search experience we need, and the speed that I talked about. We need to rely on a really strong infrastructure. So we are not working with AWS or anything like that. We have our own hardware that we spread around 15 different regions across the globe, so that we can reach your customers where they are. So first, maybe what should a developer use an API instead of building his or her own solution? There are many tools and solutions in the open source world, but actually being able to provide a really good search experience is tough. It requires a lot of different skills, from the infrastructure, the backend, to the solution itself, which are pretty complex. So from scalability, sharding, synonyms, or typo tolerance, all those are required to make a really good search experience. Along the years, we've been live. We've experienced a lot of different use cases with our different customers. And we've seen that they're all really different needs. They have different needs and different requirements, from the media vertical to the e-commerce or the mobile world. It has been a real work to actually identify those specific needs and tackle them. For instance, quickly to demonstrate a few examples, Periscope, one of our customers, have a really cool search experience where by swiping and panning through the map itself, each time you do that, it's actually performing API request to our servers and refreshes the whole content of the map. So we are going far away from the simple input search box. Twitch, another one. This is another use case, cross-platform, and the main core focus they had and need was near to real-time indexing. When you have live streaming videos, you want the content to be available and searchable as fast as possible. So how are we able to provide this kind of search experience? Pretty straightforward. we have a few components. The main one where Algolia lives is the bottom one on the hardware side. You can see that there is a REST API in the search engine block, which has been designed from the ground up from our two founders. It's not based on any Lucene technologies, so custom made. Then the other components are more on the developer side. You have the front end and the back end, and that's where we also are involved with the API clients. On the front end, you have an API client that will most likely be JavaScript that will take care of pushing the queries to our hardware and get back the information and display it. And on the back end, you will most likely sync with your database and external feeds. So we have a whole bunch, variety of API clients that we've developed along the years, front-end ones, back-end, and all the different most popular languages. Also frameworks to make the implementation even faster, and also have a bunch of integration for CMS and e-commerce platforms. So few steps to build an implementation with Algolia. It's pretty easy. First, you sync your data on the back-end from your database. Second, you configure how and what relevance means to your business, and to, for instance, which attributes of a specific record or which business metrics you want to take into account. And then the search on the front end to display the result and to get the queries. So here in code, the same steps: sync data and configuring. This is on the back end. This is the JS client, which works both on the back end and on the front end. Really simple. You instantiate the client, you authenticate with an API key, and you push some data. You configure which settings you want on the data index, and then in the front end, you can query either with a simple, straightforward query string or with a more advanced, refined. So this was the third part was for web implementation, so desktop mostly in JavaScript. But today, the way we consume content is most likely and most of the time on mobile. And tackling the mobile search is quite another challenge in itself. Even online, we still have for the app itself a few key points to help the developer get right. So the design, search screen is not search screen, but the screen itself of the phone is quite small, so every pixel counts. The usability, each keystroke is a pain when you're in the metro or walking, so you need to make that count. And last but not least, the environment is really the key part here, because when you're on the go with your mobile, you're not really sure if you're going to have connectivity or not. And that's where our new feature comes in, so going offline. A small point about the history of Algolia: we actually started as a fully offline, completely embedded in the SDK back in 2012 to enable on the iPhone 3G at the time, people to search through contacts and small data sets like that. And then we pivoted to a hosted search with much more features. But today, as we grew, we figured that it was really interesting to fall back to that use case and provide a good solution to that too. So why offline search is painful to implement, and why in most cases it is not implemented at all, is because the really powerful search feature that makes search a really good experience are really hard to implement with the technology that exists. Most likely, if you're on a mobile developer, you would use something like a SQLite with a full text search extension, but this has really limited features like no typo tolerance, no faceting. So, and another downside is that you have to code twice, one for the online search and then the second solution with SQL for the offline. So you have to maintain two parts of the codes, two different technologies. So that's really painful. Before diving a bit more about the steps we take, I wanted to quickly define what we think of offline search is at Algolia. The ultimate goal is to make the switch completely seamless between online and offline to provide the best search experience to the end users. Still the same goal in the end, but to do that, you cannot rely on usual approach for offline, like caching or prefetching. Caching meaning just keeping in memory previous content that has been consulted by the user, or prefetching meaning trying to guess what's the user is gonna want to search next. This is not what we at Algolia think of a real good search experience, where you might not know exactly what the user wants, and it's really too restricted. So the approach we took to build that offline SDK, you might recognize the bottom part, which is the same from the online one. The offline SDK is on the top left hand side, and basically we embedded the search engine part from the server, trimmed it a little bit, and pushed it inside the SDK itself. So that allows us to provide best of both worlds. When the user has connectivity, you can go the normal way, use the API clients and ping the servers. And when it doesn't have connectivity, then prior to that, the app would have synced, following a specific strategy that you would have defined, some of the indices, and would have stored them and built them inside the local file storage. And the engine that is living inside the app itself would then take the lead and populate the results to display on the mobile UI. So a few specific features that we had to develop to be able to do that. First, we did a few modification to the basic classes that we have for the client part and the indices. So the mirrored index is basically an index that will be synced from the online server, and you can decide if you want to sync the totality of it or only a partial subset. We don't have any hard limits on that, so you're totally in charge and you can do whatever you want. The data selection query part allows you to specify which subset you want. The offline index allows you to build from scratch without any counterpart on the Algolia server, an index that will be able to search directly on the mobile. And on the sync strategies, you can favor an online only, offline only, or fallback on failure, or fallback on timeout, depending on your needs. The integration is pretty straightforward. You import the SDK on iOS through CocoaPods, on other platforms through your favorite package management. Then you set up a singleton for the search manager that will take care of handling the indices themselves and syncing them. And you configure the syncing strategy. I'm going to dive a little bit more in the last part of with the snippets on how you can do that. And then you just plug in your view control, which takes care of the UI. A few challenges that we had to face being able to compact that full search engine inside the SDK itself was mostly related to size. So we had to trim down a few features which are not key, but for instance, we handle natively on the online plural dictionaries in 40 different languages. So that takes a lot of space, so we had to not implement that into that version. And the synonyms feature also are a bit trimmed down. And on security, we needed to make sure that the use of the offline was only available to people who had subscribed to it, so without connectivity. So implementing a key system to check that. One of our customers that has a really cool implementation of that new feature is All Trails. You might know that app. It allows you to search for cool trails in your area. So when you have a full online connectivity, then you have the full experience. And when you're lost in the mountains or the forest, then you fall back to the offline mode, where you will be able to search through pre-synced content or the content that you would have seen a bit earlier. And now the last part is just to showcase quickly how easy it is to implement it. So this is a Swift implementation. I'm showcasing here the search manager singleton that basically takes care of holding the indices in the app and making them available to all the different view controls in your app. So pretty straightforward. You instantiate the client, the index, and then you initialize them. For the offline implementation is the same part. You see there's a bunch of more code, and this part needs to be done for the configuration of the syncing. But when you think about it, it's only like something like 50 lines of code added just to enable this kind of search experience offline. So pretty easy to do. And the good part of it is that when you come from an online version that you previously implemented, all the view controllers that takes care of the UI, which is most of the work when you're developing mobile apps, stays the same. So you don't have any work to do on that front, as it works seamlessly with the existing API. So that's it for the talk. Thank you for listening to me. I'd be happy to answer any question you might have, and I'm here with a bunch of Algolia fellows tonight, so feel free to reach out to us. We'll be happy to chat with you. Thanks. That's not in a specific date in the roadmap, but that's something that we have in mind. There's other constraint due to the browser itself, which is more restricted in terms of volume of data that you can hold. But that would be something interesting to explore. This would be more in the hands of the developer teams on the mobile side, and it's basically for the moment it's done hand in hand with the core team that does the engine. And we are a pretty small team for the moment. We're around 40 to 50 engineers, so it's still manageable, and communication is easy. Thanks, you all.